Section 13.3 is a review of the techniques that we already know for synthesizing alcohols. Last quarter we learned a few different ways to make alcohols, and we're going to use them again this quarter. So we're going to just review the things that we already know before we learn any of the new techniques. We're going to be reviewing substitution, SN1, SN2, and also a couple addition reactions. So we learned last quarter that you can take a primary alkyl halide and react it with a hydroxide ion. It will do an SN1 reaction to produce a primary alcohol. And that's SN1. Again, this is just a really simple motivation for this reaction is the reactivity of the hydroxide ion. It comes in and attacks the carbon, kicks off the halide leaving group, and you end up with an alcohol. We also learned about a similar reaction with a tertiary alkyl halide using water as the nucleophile. It produces a tertiary alcohol. Again, this is, oh, I wrote this backwards. The first one is SN2, not SN1. With water, it's SN1. And in this reaction, water, not being a great nucleophile, doesn't attack anything, but the tertiary alkyl halide falls apart, forms the tertiary carbocation. The tertiary carbocation is then reactive and then reacts with the water, and you end up with a tertiary alcohol. Secondary alkyl halides usually are not useful for producing secondary alcohols. If you try to do an SN2 reaction with a secondary alkyl halide by reacting it with hydroxide ion, you're going to mostly form the alkene, not an alcohol. So you're going to remember that with secondary alkyl halides, we have competition between SN2 and E2 and SN1 and E1. With a strong nucleophile like hydroxide, we're going to have competition between an SN2 and an E2 reaction. And with a secondary alkyl halide, the E2 reaction is going to win. Most of your product is going to be an alkene. You're going to get very little alcohol. If you try to do a secondary alkyl halide SN1 reaction by using with water instead of with a strong nucleophile like hydroxide, this reaction just isn't really going to work. In order for this reaction to go at all, the secondary alkyl halide has to fall apart to form a secondary carbocation. And even though secondary carbocations are stable, sort of, they're not stable enough for this reaction to proceed at any decent, reasonable rate. So this reaction is really slow. So this process of converting alkyl halides to alcohols really only works for primary and tertiary. Thankfully, we have lots of other ways to make alcohols. This isn't it. You also learned last quarter some elimination reactions that produce alcohols. We're going to draw these elimination reactions with really simple alkenes, but it doesn't have to be the propene. It's going to work with any alkene. The first reaction that we learned that produced an alcohol was the acid-catalyzed addition of water to the alkene. In this reaction, we take water and sulfuric acid, and we add across the double bond an OH group and a hydrogen, which I'm not drawing in. This reaction follows Markovnikov's rule, meaning that the hydrogen that's added to the double bond goes onto the carbon that has the most hydrogens already present. That's the carbon at the end. The OH group goes onto the other spot, and that dictates the position of the OH group. And it also is susceptible to rearrangement. Because this reaction proceeds through a carbocation intermediate, the hydrogen comes on, and we have a carbocation intermediate, which then will undergo rearrangement if it can to form a more stable carbocation, so you don't necessarily get direct addition across the carbon-carbon double bond. We learned that we can avoid rearrangement by using a slightly different set of reagents, oxymercuration, demercuration, which uses mercury acetate, HgOAC2, and water. And then in a second step, sodium borohydride. This reaction produces the Markovnikov product without rearrangement. So this allows us to have more control over the products of the reaction. The trade-off is that the reagents are more toxic and more expensive, but sometimes necessary to get the product that we want. And then we also learned that we can get the OH group to go onto the other carbon of the alkene, do an anti-Markovnikov rearrangement, or anti-Markovnikov addition, using BH3 and THF, followed by hydrogen peroxide and hydroxide. And that will give us the anti-Markovnikov product. So in terms of addition, we have the ability to put the OH group basically anywhere that we want it to go. And that is all the reactions for making alcohols that we know to this point. You can refresh your brain with these reactions with conceptual checkpoints 13.7 and 13.8. And again, those problems are just still reviewing these reactions that we've already learned. Your study questions, study question for this section is, how do you prepare an alcohol by substitution or elimination? Sorry, by substitution or addition. And tomorrow we will start learning some new ways to prepare alcohols.